Hey, do you guys hear some sort of buzzing sound? Because I'm looking at page 11 of the use substitution packet today, and I see a bumblebee at the top, and he's just buzzing, saying, be careful with the examples that you see on this page. More complicated, enter at your own risk. But I thought these ones would be really cool to talk about now that we've gotten a few days of use substitution under our belt. There's a much less obvious U choice on this page. So we're going to kind of weigh together the pros and cons of different choices. I was trying to think of a good joke for you guys. So I grabbed my go-to Laffy Taffy. This is a strawberry flavor. I have not looked at this joke yet. I wanted you guys to get my true reaction. And the question is, what type of truck is never lonely? And the answer is a pickup truck, right? Because he picks up people. What's a dryer's favorite exercise? And they are spin class for a dryer, spin cycle. Now we're going to look at these examples on page 11, starting with these two trig examples. So take a look here and try to think of what we would make you. I'll leave myself a little bit of room over here to do this side work with you. And we've got two different trig functions, a secant that's to the fifth and a tangent that's just sitting there. And the question is, how do we pick? Do we want u to equal secant? Do we want u to equal secant to the fifth? Or maybe u should just equal tangent. And those are three possibilities. It could be any one out of the three, but which one would you go for? You couldn't say one is more complicated than the other. You could say either secant or tangent is more of an innermost part of the function. I'm wondering if you think secant or tangent is more inner. And I'm going to go for secant. When you see secant to the fifth, another way to write that is secant of x raised to the fifth times tangent of x. That means this is inside of parentheses raised to the fifth, and this is what you want. You want to pick the inside of that to let that equal u. So I'm going to let that equal secant of x. Another reason why it just coincidentally is a great choice is that its derivative actually does appear in the problem in a way. Its derivative is secant tangent. That's what we're about to write. And I'm hoping that'll make things cancel for us. So du dx is the derivative of secant, which is secant x tan x. And then it'd be pretty quick to solve for dx, right? Secant of x, tangent of x, dx. Okay. And then getting dx by itself, du over secant of x, tangent of x equals du. So this is what we're going to go for and see how it works out for us. Now we'll go back to the original problem. We're hoping that subbing back in is going to make it simpler to integrate. We want to take the integral of, instead of writing secant to the fifth, can you write u to the fifth, which shouldn't be bad to integrate. Tangent of x, like that. So we're not out of the woods yet. Now we have in for d x, sorry about that mistake there, in for dx, right? We were getting dx by itself. We're going to plug in du over secant x, tangent x. And this is the step where hopefully all the x expressions cancel, and some of them do, or at least one of them does. The tangent of x should cancel with the tangent of x, but that's why this problem's on this page marked as more complicated, because not everything canceled. I'm still left with an x expression. You've got u to the fifth du over secant x. And I'm wondering if I'm missing something. Did I forget to plug something in? Well, sure, it was nice that the tangents went away. Is there a way to make this secant go away? Could we write it in terms of u? And the answer is yes, we can. We said that u was equal to secant of x. We can sub a u in the bottom of this fraction and make this problem a lot simpler to integrate. So we're going to go back in and write integral of u to the fifth du over u. That's a trick we haven't had to use yet earlier in our examples. So now we can reduce this a little bit, right? U to the fifth divided by u, we can cancel this whole u with one of those 5. And now we're just integrating u to the fourth. So I am very happy with the version we have here. We can use our regular anti-differentiation power rule. You're going up a power back to u to the fifth, 1 over 5, and then a plus c. Indefinite integral. Sub back in. U is equal to secant of x, so final version, 1/5 secant of x to the fifth, and then plus c. And that was 1 down. Okay. The next one follows right from the one we just did. Two different trig functions, still tangent and secant, but no easy out here. When I'm choosing u, last time I said, ooh, go for, what did I say? Go for secant, because it's inside being raised to a power. But I can't just use that trick here because both of them are being raised to powers. Yikes. The tangent is raised to the 7th, and the secant is raised to the 2nd. So I can't just say one of them is raised to a power, the other one isn't. I have to pick. And sometimes it's a 50-50 choice we're just forced to make, but there is a good option here. I'm wondering, they're both inner because they're both raised to power, so I can't use that tactic. Does one of the functions' derivative appear? Does either tangent's derivative appear pretty conveniently, or does secant's derivative appear? You probably could make a case for both. But I'm going to go, if it's a 50-50 choice, I'm actually going to go with tangent. And I think you're going to learn why in this very next step. In the very next step, when we write its derivative, and I think back to my trig derivatives, I get this. I just get lucky and I get secant squared of x. Tangent was the right choice for number 2. It's raised to the 7th power and its derivative is sitting right next to it. Keep on going with the side work. du equals secant squared x dx. And then let's get dx by itself so we're ready to plug in the pieces of the puzzle. Du over secant squared, and then just a u we need as well. Okay, so we go back up to the original, trying to make it look simpler. Integral of tangent to the 7th, how about u to the 7th? Secant squared x, we'll leave it there for a second, not anticipating it being a problem for very long, because in for dx, we can sub in that fraction, du over, what do we say down here? Secant squared x. And that is what needed to happen. So a way to make this problem a lot simpler as well, we're integrating u to the 7th with respect to u. That'll be 1/8 u to the 8th plus c. And sub back in. I'm going to write this in a cool way, 1/8 tangent to the 8th of x plus c. And we'll call it. Okay, 2 down. All right, I'm feeling pretty good about this page so far. Let's see what's in store. Okay, 3 and 4. We haven't seen very many like these, and they both have similar strategies, I think. I'm looking at number 3, and I notice I can't really go with the tactic of picking the more complicated item, because if I'm just looking inside of the parentheses for number 3, x plus 3 and x minus 1 are both pretty similar. They're just linear binomials. However, one of them is inside parentheses raised to the 5th. So just like in number 1, how we went for the one that was raised to the power, can you make u equal to the inside that's being raised to the 5th power? Let's see how far this gets us. This problem is going to be at least a 1 star. So let u equal x minus 1. Du dx, that's the next step. I'm a little nervous about this because I don't really get much, do I? I get the integral of x is just 1. So du actually equals dx. It's not really going to help me with making x stuff cancel, but I put it in the packet, so it should be solvable. Let's see what we can do. So we'll go back up to the integral. We'll sub in what we can for starters. So we can plug in nothing right now for the x plus 3. That's going to be a little problem for later. We can write u to the 5th, since we did call u x minus 1. And instead of writing dx, we can write du. We said du equals dx. And now our focus shifts to this guy right here. We have to find some way, any way, anything on the page that can help us get rid of that x. And it's something we haven't done yet. This is a process called back substitution. And I spelled it wrong. Substitution, how about? So that means we already used some u substitution here. We let u equal x minus 1. Well, we set this equal to u because it was convenient for us. We should be able to use that substitution in any which way we want. If u equals x minus 1, maybe I could get an expression from this for x in terms of u and sub it, back substitute it in for the x that we need to cancel in the problem. That's going to be the way to make this simpler. So what I mean by that is a little bit more side work. Can you take what you already wrote here and solve it for x? So we'll make it u plus 1 is equal to x. If this circled thing is true, then this circled thing must also be true. All you're really doing is just adding a 1 to both sides. This should do the trick. back in the original problem, instead of writing x plus 3, can you write this plus 3? Write u plus 1 plus 3. And I'll show you. I'm going somewhere with this. We're going to make this simpler in a second. That's like saying integral of u plus 4, right? Times u to the 5th. This is going to be no problem for us. We can simplify this. We can distribute in. So I'm going to distribute the u to the 5th to both parts. Make it u to the 6 plus 4u to the 5th integrated with respect to u. Okay, so we're going to go, we just have 2 parts to integrate this time instead of 1. We can, I don't want to scroll down too far. We can now, let me use this space. We can make this, let's drop the integral sign and actually take an antiderivative. So 1/7 u to the 7th. And then we'll say plus, we're going up a power. So 4 divided by 6, right? 4 over 6 u to the 6 plus c. Okay, so that was a huge step there to get that all in terms of u. Integrating wasn't too bad. Now the sub back in, so our final answer can definitely be written in terms of x. So 1/7, what was u? X minus 1 in parentheses to the 7th, plus, how about 2/3 instead of saying 4/6? X minus 1 to the 6th, and then plus c. Feels pretty good. These are some of the most complicated integrals we've ever taken together. I would like to scroll down to the bottom of the page and take a look at number 5 before we go. We've seen problems similar to this before, but not exactly like this one in terms of what's going to cancel for us. So not to scare you, but I want to actually circle this and give it like 2 or 3 stars of difficulty for a let u equals. One of the biggest hurdles of the problem is usually picking u, and this problem is the kind that drives me nuts because I want to pick the top. I'm confident in all the other problems in the packet. I've picked the more complicated part to be u, but that's just not going to get us very far here. The derivative of the top is just 2x, and we're just going to have a problem later with trying to cancel this with that. It just won't fly. So if you want to bear with me, and I'm saying that this problem is very out of the ordinary, it's the first time ever we're actually going to pick, I just wanted to show you the case, we're going to pick the simpler item to call u. The good news is du dx, just like the last one, is going to be 1, easy to handle, and we've got both of these puzzle pieces to use as a sub-in. So once you go back up to the original, sub in for what you can right now. So the top we're going to leave, x squared plus 4, we'll have to deal with that in a second. But the bottom we can make u, and dx we can write du for. Now we got to think for a second. We got to think of our best way to get rid of x squared. I don't see anything canceling to make that x squared go away, but last time what worked pretty well was we took what we already used here. This is going to be some back substitution again. I'll say back sub. If you set u equal to x plus 2, would you agree with me that u minus 2 would be a way that we could say x? I mean, all you're really doing is subtracting 2 from both sides. So we want to take this substitution and plug it back in for x into the original integral, or the integral we've already subbed into. So this is the integral of, instead of x squared, can you write u minus 2 squared plus 4 over u? And believe it or not, this is a simpler way to look at the integral. There's algebra and canceling that we can do here to make this easier to integrate. So we're going to simplify the top, square through the parentheses. So u squared minus 4u plus 4 plus the other 4 that was on the outside gives you a plus 8 up top. And we want to pick our best strategy to be able to simplify. U squared minus 4u plus 8 all over u du. I'd say take each individual term and divide it by u. So like instead of u squared over u, you can just call the first part u. The second part, canceling those u's in the middle, minus 4. And the last part, plus 8 over u, which has its own rule. Du at the end. And now we want to integrate. U squared over 2 minus 4u, we'll tag on the variable, plus, remember this rule, ln rule, 8 ln absolute value of u. Like that. The last part is the sub back in terms of x, and u is equal to x plus 2. So x plus 2 squared over 2 minus 4x plus 2, and then plus 8 ln of x plus 2, absolute value. I apologize for rushing the last bit of this, right? I would have actually taken this a bit slower, but I knew YouTube was going to cut me off at 15 minutes. They always try to get you, but I love you, YouTube. Thank you very much anyway. I hope you guys have an excellent rest of your day, and talk to you later.